So if we have a wee look at this second one, so it's a wee bit blurry there. So I've redrawn it there. So that's our circuit, and I've removed the load resistor because I'm going to do my Thevenin first. So I've removed my load resistor and I've written my AB there. My AB terminals, they aren't open, they're closed. There is a current path through there. So I'm going to find the voltage across that 10 ohm resistor. To draw it more conventionally, I've drawn that equivalent circuit. So that's really what you're trying to do. You're trying to get the voltage across this wee part in here. Okay, so this resistor here is the same as this resistor here. This is a redrawn network of this. So you come out your 12 volt supply, through your 5 ohms, hit a junction. One path takes you through the 10 ohms and back to the supply. The other path takes you through a 5, then a 10, then back to the supply. So it's an equivalent circuit. These are the same. From this, if you're wanting to work out the voltage across that Thevenin part, what you'd probably do first is you'd work out the voltage across the parallel part and then divide that again. So you wouldn't use this circuit necessarily. You'd probably start off using a circuit like that. So you start off doing that, and you'd work out what your value for VP would be. So your RP first and then VP. So to get your RP, doing the product over the sum if you like. In one branch you've got 15 and the other branch you've got 10. And that'll get you your RP value. So that's 6 ohms. So then to get your VP, you would do the voltage, which is the supply voltage there that you're going to divide. Over the 2 and added together in the series string. And that rounds to 6.55. And that'd be the voltage across that parallel part. So now we know we've got 6.55 volts across this parallel part here, or this equivalent resistance. So that means you've got 6.55 volts across this whole part here. So this VP is the same as this VP. So you would have 6.55 volts across this 10 ohm resistor, and you've got 6.55 volts split between these two. So we're going to do a second voltage divider in this parallel section, and we're going to divide the voltage VP. Okay, so we're in that wee section for VP. So our second voltage divider, which is going to get us our voltage AB, which is our V Thevenin, we're going to divide that VP. The one we're interested in is the 10, and it's over the 10 plus the 15, 10 plus the 5, getting you 15. So 6.55 times 10 divided by 15. And that gets you 4.37, rounded. It's 366,667. So 4.37 rounded. So you've redrawn your circuit into an equivalent. Then you've worked out what the voltage across this parallel part is using the second equivalent circuit, taken that value back in and done a second divider there. Get the voltage VAB across that 10 ohm resistor, which is the voltage there. So the second task that you have to do is to work out your R Thevenin. So you're looking at the same circuit again, but you're shorting out the power supply. So you don't have that 12-volt supply there anymore. You're keeping that 5 ohms. 5 ohms. 10 ohms. This other 10 ohms. And you're kind of pretending that your power supply is over here. And you're working out what your resistance is looking in this direction. In a lot of the kind of books you see like a wee picture that's meant to be like an eye looking in from that direction, but it's really hidden on your power supplies at that side. Now if you're to draw that in a more conventional style, as a more kind of equivalent style, then starting off at the top, you'd come down, you'd have a junction, wouldn't you? One path would take you down through a 10 ohm, then back to the start. The other path would take you through a 5 ohm, which is this one here, take you into a further junction, split into a 5 and a 10, back into a junction, and then back to your supply again. So that would be the equivalent circuit of that. If you're struggling to redraw them, then just go through that process of looking at where everything goes. And if you can't quite fit it in, just try again. This 5 and 10 down here, or this 5 and 10 here. So if I labelled my junctions, for example, say I labelled that junction X, right, W, X, Y, Z. Say I went for that. Then that's W, that's X, that's Y, and that's Z. If you're looking at the same thing. Now when you reduce this, your first step would be to go to this. So we have RP in here. Then from that, you go to this. That stays the 10 ohms. That'll be some kind of RS value, say, for R series. Then from that to this. And that would be your R total. So the difficulty usually is understanding that this looks the same as this, because all this is quite straightforward. Yes. So now all you have to do is work out your value for RP, RS, RT. So you're using techniques you already know. So 10 and 5 in parallel, you can do that. And your R total is your R Thevenin. So your next step will be to do your Thevenin equivalent circuit. So now what you'd do is you'd go on and you would do your Thevenin equivalent circuit. So you have your Thevenin equivalent circuit is always going to be your Thevenin resistance your Thevenin voltage, and your load resistor added back on. So 6.55 volts was for your Thevenin voltage. Your Thevenin impedance 4.54 ohms. And your original load resistor was 4 ohms. So if you wanted to get the current, V over RT, you do it that way. And your voltage, you could either do by a divider, by doing your V Thevenin times RL over RL plus R Thevenin, or ILRL. And that would be that one done. Sorry, I've made a mistake. I've copied down the wrong value. For my V Thevenin, I've copied down my V parallel. It's not V parallel, it's VAB, the 4.37. Been corrected. I'll take my 4.37, move it in there. Change that. So that changes my current to 0.512. And makes my voltage 2.05 rounded. Hopefully that's it now.